So I just thought I'd start off with the remit of the data science section. So it's to be a professional body, not the professional body, that represents data scientists in the UK. It'll organise meetings for a broad range of attendees and generate outputs. So not every section sort of generates outputs. So the idea was to try and generate some outputs from this group. And you'll see the areas of this are very specific. So we want to promote good practice by saying what good data science looks like and what it doesn't look like. So if you're coming here to expect a definition of data scientist or a definition of data science, you're going to be disappointed, because essentially we thought that was an unproductive thing to do. Lots of people have tried it, no one comes up with the right answer, and that labeling we felt was unhelpful. So we're not going to go there and define data science. We want to promote the statistical aspects of data science, reinforcing the statistical framework. We would be remiss as a society not to want to at least bring about a discussion around the statistical framework. We recognize that other groups are involved, but there is a statistical framework which needs to be highlighted. Be a trusted voice on data science to employers, including input into consultation exercises, supporting the data science community throughout the UK. You'll see we did some workshops, and we deliberately went to different parts of the country to do that. We weren't just London-centric. Support the pipeline and career development of data scientists and statisticians. So statisticians who want to become data scientists who want to become statisticians, ignoring, in effect, the label. But essentially, we want to support statisticians and data scientists. Looking at emerging topics, and certainly one of those being around ethics. So ethics, privacy, algorithmic responsibility, lots of good work being done in those areas, but they were certainly hot topics. And then foster multidisciplinary connections. So we've worked with the actuaries in particular, IFOA, we're talking to the Operations Society. So basically we will talk to anybody that's willing to talk to us. So that's the remit. And then the work plan for 2018, essentially we came up with a document that was done by Harry Powell from Jaguar Land Rover, who was at the time at Barclays. And he basically came up with 12 questions to ask, and we used that at our launch event. From that, we then got feedback and focused on 4 questions in particular. And then of those 4 questions, essentially we went to a meeting with Bristol data scientists. The input from that then formed the output for essentially the Manchester conference, or the Manchester workshop. The output from the Manchester workshop became the input to the Turing one. And the output from the Turing one then became the input to the Edinburgh meeting. And so basically we've just reiterated or iterated as we've gone along, and we now have a nice document which we'll make publicly available. We have some slides on it, although I think it's going to be pretty hard to read, but that's the sort of thing we're going to go through. So we're going to go through essentially the findings of those workshops, and then based upon the output, we'd feedback the RSS conference, hey, this is where we're heading, and then determine the next steps. And you've got an opportunity as well to input into those next steps. So these were the 12 questions. The 4 we're going to focus in on: what does a good data science workflow look like? How should data science fit into the structure of an organization? What do executives and managers need to know about data science? And what is a data scientist's responsibility to wider society? So you can see these other areas are still ones we want to talk about at a subsequent time. Career paths for data scientists, lots of meetings on that. So lots of areas we haven't yet covered. So these are the 4 questions we're going to go through today. And with that, Paddy, I think actually I'm ahead of time, so I'll pass on to you.
So I'm going to report back the aggregated readouts from the 4 workshops under what does a good data science workflow look like. And what we've done is put this together into a more document and slide format, so you don't need to read all of the words on the slide, because I'm going to pull out the main issues and things that have come out of the 4 different workshops about what a good data science workflow looks like. And one of the things that came out most clearly was about having a clear question. We'll discuss that in more detail with emerging issues later, but that was something that people talked about a lot in terms of driving forward the data science work and being part of a good data science workflow. Related to that is about having milestones and outcomes, having these very clearly set, and of course that has to be done iteratively, working with customers and users. having good engagement, making sure that you can set milestones for very specific outcomes and have a very clear end point. All of these things were thought to be contributing to good data science workflows. Ethics also came up, and that was one of the other questions that we're going to discuss in more detail. But one of the features of good data science workflow was that ethics is embedded throughout. So it's not something that you think of when you suddenly identify a risk, or when you get to the end of the process and think, oh dear, let's think about ethics. It's about embedding it all the way through the process. And sorry, I should have also said that connected to being customer focused and being iterative about the way that the workflow is developed is about being flexible. So making sure you're balancing short and long-term activities, changing priorities, and outcomes from the process itself as well need to be built into how the workflow is developing. We also need to make sure that, of course, as Andy was saying, that statistical rigor is part of the data science process. It was very interesting to listen in the plenary to the description of computer science, informatics, statistics, and sectoral experts. I guess from a data science point of view, we would say that statistical rigor underpins good data science. And of course, an iterative part of the process of engaging with customers and users is also including sector experts and making sure that they have feed into the process and can shape it in the right way. And transparency is also very important, particularly when it comes to limitations and to uncertainty. So I guess statistical rigor covers the very clear communication of uncertainty and the limitations of the method. And transparency is very important for maximizing the value of what you're creating, for example, in government statistics, but it's also very important as a way of putting uncertainty out there so that there's no ambiguity about how the results can be interpreted. And something else that came out was human oversight. So maintaining human oversight. So I'm pulling out some key connected issues here. And we'll talk about how these outputs will be more available at the end of the workshop. But maintaining human oversight to make sure that all of these things happen, i.e. that customers are involved as they can be, that ethics is embedded as it properly should be, is an important outcome from these discussions. So it's not about just building a workflow and a pipeline and letting it do its thing and then coming back and checking in on it every now and again. There needs to be someone who's responsible and there needs to be full oversight of that. So just revisiting some of those as emerging topics. And when these emerging topics are usually ones, certainly in the case of Edinburgh, where the Edinburgh workshop, where people really wanted to continue to discuss them and there wasn't a clear consensus in the room that was a sort of obvious best answer to the problem. And so one of these is about blue sky data science projects versus a standard data science project with a specific problem and a specific desired outcome. Is there a difference between them? Is one of them less data sciencey than the other? Are they equally as valid? And based on our impression from the workshops, this depends very much on the context, and on the organization, what the goal is. From my own experience, the key to the difference between these two things is being very explicit about which one you're embarking on at the beginning of the process and what your stop points are if you've got an exploratory process. But it's also very important to make sure that learning is documented and is available. So if you set off on an exploratory data science project, to make sure that you record everything so that no one else needs to do that exploration again in the organization or elsewhere. And that's related to, do you have to start with a question? I would say no, but I wouldn't say that that is the only answer. There are other ways that you could defend a yes answer to that. And if you do have to start with a good question, what makes a good question? And again, no consensus on the answer to this, but it's very interesting to discuss why people think this is a good data science question, that's a good data science question, because quite often it's context dependent. So I would say, from first principles, there's nothing that can't be a good data science question at the beginning. But once you've started to look at your data sources and your ability to answer it using a data science workflow, then you can knock off quite a lot of things that are no longer good data science questions. But that's also open for debate. I'm going to now move on to the next question that we're focused on, because we'll save all of the questions and discussion for the end. And I'm going to talk about ethics, which in the workshops was posed as, what is a data scientist's responsibility to wider society? And interestingly, the reason that Andy has grouped these two together, workflow and ethics, is because one of the outcomes from the workflow was that ethics must be embedded in it. And one of the key things that came out of the ethics discussions was that it needs to be embedded in the workflow. And that's not just about governance, it's also about culture. So I end up thinking about this sort of things through the lens of the Government Statistical Service Code of Practice. So it's not just about saying who is responsible for what, at what stage of the process. It's about making sure that the people who are doing it have a real sense of professional ownership of the whole process and of the consequences of the outcomes and the outputs, how they can be used, exactly what they might be used for in the worst case scenario, where it's come from, what they could be combined with, and that sort of thing. So not just on a governance level, but also on an individual code of practice level. And one of the ways to do that is to engage with ethical bodies. These might be sector specific, they could be more general, and with data ethics principles about security and privacy. Particularly important for making sure, well, the code of practice point is particularly important for making sure that responsibility isn't devolved within an organisation when you have perhaps a new and very complex series of processes that are being done by an organisation for the first time. You need to make sure that people aren't just shunting responsibility to the side or along the line. And part of that is about the impact of models on decisions. So being aware of biases, being aware of errors, assumptions and risks, and making sure that all of those are not only in your mind when you're carrying out the process, but are available as part of the output, as a very, very clear expression of uncertainty and limitation of the findings. And as I said, transparency is a very important part of that. So making sure that working is transparent, but also all of the assumptions and aspects of the models that have gone in. And one aspect of that is about whether more explainable and understandable methods are more ethical in some way. This was another interesting aspect of the discussion. And I also believe that there wasn't consensus on this. Some people would say the simpler the model, the more ethical it is, because it's more explainable, it's easier to identify why an outcome has become an outcome. And that's something as well that I think we can continue to discuss. Really interestingly, maintaining human oversight is also a big theme that came out of the ethics debate, exactly the same as it did from the workflow debate. In the sector that I work in, this is particularly interesting because last week a paper was published in Phil Trans, which was a review of machine learning methods for disaster and humanitarian response, with a case study of using drone and satellite imagery data from refugee camps in the Middle East and Africa to identify and count structures. And their headline conclusion was that the full automation of this process we're not at that stage yet. The full automation of this process is not yet possible. But the augmentation of human analytical capability through these methods is entirely possible, but it requires a lot of human oversight. So it's interesting to see that research in this area is bringing up this key element that's come out of both aspects of these two workshop questions. So some of the other emerging topics were about the difference between data ethics and business ethics, i.e., is there a gap between the different ethical frameworks that we're using to think about ethics related to data science that has not yet been filled? Again, my bias as a government statistician is to go to the GSS, the Government Statistical Service Code of Practice, and to suggest that that individual level responsibility lens is a good way of filling that gap. But I'm not sure I know enough about the workings of business ethics and the ethics in the corporate world to be able to say whether that's true or not. And also it might depend very much on the context and on the sector. So I think that's another interesting area that's open for more debate. Also, it's easy to say ethics should be embedded in the workflow, but how do we go about actually doing that? How can we have effective nudges on data scientists to embed ethics as they go through the process? How can that be worked into team dynamics and individual working dynamics as you are sitting there coding? How often do you need to check your ethics, as it were? And yes, so this is sort of covered about different routes to data science profession in different sectors. One of the things that's been really interesting from my point of view of taking part in the data science section of the Royal Statistical Society is learning about data science activities that may not necessarily self-identify as data science activities going on in the actuarial world or in industry, and how related they are to things that are being talked about in government stats and in academia. And of course, we also discuss bias, whether it's acceptable, whether it's unavoidable, how do we stop sensitive variables being included. And I think some of that is an ethical question about being careful to make sure you understand the risks, what data could be combined with the data we're producing here to do something that would be unethical. But it's also about what you do if you know that your training set, and there's no other training set, has bias inherent in it. Is there a way to counter that bias? Should it be discounted? Is there a way of communicating uncertainty effectively enough that it doesn't matter if your training set is biased in some way? Or should we at source say this is not acceptable if there's any bias? Or would we be ruling out an enormous amount of useful data science if we were to take that approach? And also, who is responsible? So as I said, if you imagine an organization with lots of different bits, and the data science workflow starts connecting up bits of this organization in a way that they have never been connected up before, who's responsible for the whole pipeline and for the whole project? And with that, I will hand back to Andy for the remaining two.
So it's probably worth saying that, when we did all these workshops, I think what we came to understand was that there was no single solution to any of these problems. So it very much depended upon context and the type of organization that you're dealing with. So the next question was about what do executives and managers need to know about data science. So the data science section deliberately includes people from business, as in commercial business, from academia, and from government. And so you can interpret, executives, managers, anybody within the organization at the top or near the top, what do they need to know about data science, whether it be in academia, as I say, a big pharmaceutical company, or within a government department. So, as you see on these slides, basically we were focusing a little bit on the principles. We also have the practices, the how to do things, and the why, but we're looking more a little bit here on the what. So what do execs need to know of principles? They need to understand the strategic direction. Now, I mean, executives, that's by the very nature of what they do. Of course, they do strategy, but they need to know the strategic direction for data science and how it links to the wider business goals. Okay? And going across on the side, certainly the need to, how do you prioritize is clearly the sort of why do you do that? You need to be problem focused. I fear to some extent presenting this back to execs and see if they say, well, isn't this stating the blindingly obvious, because this is why I'm in this position. But it's interesting coming from a data science perspective. But this is what data science is for. So that execs, managers need to be problem focused. Understand how data science can add value and what sort of problems are solvable. So not all problems are solvable. As a real emphasis, I think, when we thought about execs was how do executives learn? And they love to learn by case studies and storytelling. A lot of the management books are around sort of case studies and that. So really a big focus on thinking about if we engage with executives, then certainly the need to have examples and storytelling was important. So data management. This is data management, maybe the less exciting area if you're at the top of an organization. But how do you, what's the principle here? You treat data as an asset within an organization. Incredibly important. Be a champion of good data governance, and as Paddy was talking about, ethics. So there needs to be a champion of ethics and governance as well. And then an interesting term that came up was execs need to be data savvy. I really like that. It sort of resonated with me, being data savvy, but what does it mean in practice? Data savvy. So we'll try and tease a little bit out on what does that mean. Some of the practical sense in terms of analysis, ensure that the tools and the environment are there for the teams to work on data science, whether it be your R's and your Pythons and your whole various other things. Encourage support and scientific rigor within data science. And support use of models where risks are balanced with expected benefits. So some of the practicalities here. And as you see on the practices, what we tended to sort of break this part down into sort of mindsets. So what was a mindset issue? What was a knowledge issue? And what was a skill issue? And if you look there we probably can't read it terribly well, about the knowledge. So we had a big debate about what sort of knowledge should an exec have about statistics or data science. So should they know the difference between robotic process automation, which is sort of rolled into AI these days, which essentially is a rules-based, you think of bots can be sort of in that as well, but robotic process automation, not really statistical in many ways. Versus sort of probabilistic models. And should we distinguish between different types of probabilistic models? So linear models, but also nonlinear models. And should we think about that understanding between working within a certain sort of confines, where things don't change? If you think, say, facial recognition is a good example of that. People's faces generally don't change from year to next in the sense of humans don't change dramatically, which is very different to, say, economic forecasting, where the rules of economics change all the time in the way. If you just think about interest rates, how they change by a very small degree now. If we went back many years, they'd change by a chunkier amount. So the economics changes. How do you have models that work in it where the environment is changing? Next one was products and delivery. So lead and endorse a cultural shift towards data-led decisions. A lot of talk at the moment to think about data-led, evidence-based, but is that truly the case? So evidence-based decision-making. Know when to ignore an automated decision. Then communication about articulating the benefits while acknowledging the limitations and helping to manage expectations across the rest of the business as well. So a sort of communication challenge there. And then we'll come on to this a little bit in a minute about the structure and organization as well. So align the structure with the current needs and strategic objectives. So we're not saying there is a particular structure that is right, but it should be aligned with the needs of the organization. Okay, so these were the emerging topics that came out of the session. So execs need to be data savvy. What does that mean in practice? So I'd be interested to know your views on that. Do you agree with that? What does it mean in practice? The importance of data quality, governance, and infrastructure in terms of time and cost. What sort of problems are solvable? In this case studies in storytelling. And the need to understand the risks and ensure that there are checks and balances. I mean, boards generally are there to ensure there's checks and balances within an organization. So how do you have the checks and balances as well on your data science projects? And then we move on to how should they fit into the structure of an organization? And we've got this comment here, should data scientists get out more? And we've used that a little bit. And I think that's the same as sort of statisticians. So I'm a great believer in you should understand how your data are created, how they're generated, how they're captured. If you take administrative data for government, administrative data are captured to provide a service. They're not captured to produce statistics. They're certainly not captured to be able to merge with other data sets. So should the data scientists be basically within the business? Should they be out there understanding how the data are coming in? Or should they be a more central organization? So again, no right or wrong answer, although I would say any applied quantitative analyst should be out understanding where the data come from. So 5 different models were identified in terms of organizational structure. First one was about consultancy. So if you're an external consultant or consultancy firm, essentially you have individuals that work within particular business units within an organization and help develop sector-specific knowledge. Then there's more the sort of R&D model, which Paddy talked about before, the sort of the focus on innovation. So there's less pressure for immediate return and more about sort of blue sky thinking. But again, you still need a question around that. Should it be time bound? But certainly that sort of R&D model came to the fore as well. And then the next two are probably the most common ones and the ones that I think people like the most. So the next one was hub and spoke. The idea behind that is you have a core data science team that is responsible for sort of methodology development, standardization, doing all the central stuff, bit of training as well. We know data science is often self-trained, but sort of some sort of core group. And then data scientists are then deployed into different parts of the business in a far more sort of applied domain way where they get to understand that particular part of the business. And those people can then swap around. So somebody in the core can be seconded for a period of time, maybe a couple of years, and then come back in. So the hub and spoke model, I'd say, was resonated with a lot of groups and was deemed as being probably one of the best ones. Federated was also fairly, was viewed positively. So here there's no core team, so no centralization. And essentially each part of the business has its own sort of data scientist team working in an independent manner. So you miss out on that core, so you don't have that overhead, but at the same time, it may be quite hard to make sure you have sort of standardization. But again, that was certainly seen as being a good model, and part of it can still be centralized. So you can, things like data management, storage, etc., could all be centralized within part of an IT infrastructure. And then the third, or the final one rather, was centralized. So that's really just having a centralized group that works in a core way and basically just tells everyone else how to operate from a core, so they don't actually go into the particular business units, etc. And then this is the pretty much I think almost the final slide on this. There's not too much here, but in terms of the principles, so whatever structure you have should have the buy-in from senior execs. You need to, regardless, you need to establish strong links to the business areas, and you need to develop domain knowledge. I think we're all, really, as applied statisticians, that's just how important it is to have that knowledge. You can adapt your organizational structure over time, so you don't have to choose one model and then keep it forever. So that's what we intend to cover. I hope that stimulated a little bit of debate.